Okay, so we had a question about closure here and how to work with it, and we're going to look at a couple of examples and connect it to the background theory of the closure property. Now, let's look at the first one. It says, which set is closed under division? So, we're always going to give you some operation to look at. And the idea is that in each of these sets, if we use division, and we can't escape the type of numbers in the set, then that set is closed. So in the first one, actually, this is the answer, this is closed under division. Now, the only element in the set is the number 1. So the idea is if I take 1 and I divide it by itself in any order, what do I get? Well, 1 divided by itself is still 1. So essentially what's happening here is that we use division, and no matter how we order the elements or how many times we use them, we're still stuck in the original set. We're still mapping back to the elements of the set. And that means it is closed under division. That's just the one operation we're looking at here, so it's closed under that operation. But the other ones are not, and I'll show you how, but take a minute and think about it for yourself, and then keep rolling the video. So the second one, counting numbers, that's, if we look at those numbers in a set, that's 1 and 2 and 3 and so forth. These are not closed under division because if you were to take, let's say, 1 divided by 2, what happens is you get a new type of number. It's a half, or 0.5. So because you created an element or a value that wasn't in the set before, this is not closed. So a new element or a new type of element is created. And when that happens, that means that the counting numbers are not closed. So therefore, they're not closed under division, under that particular operation, right? The same thing is true for the integers, and those are positive and negative whole numbers, right? So 0, 1, -1, 2, -2, and so forth. But again, the same idea. I could just divide 1 and 2, and still I would get this new type of number here, 1/2. And the same thing is true with whole numbers. Whole numbers are essentially like counting numbers, 0, 1, and 2, and so forth, but they also include 0. But still, I can run into the same issue. Division would create a new type of element. So none of these are closed under division, but that's different for every operation and every set. The second question, they say, which operation is the set of odd integers closed? So odd integers, of course, are the odd numbers and their opposites. So 1 and -1, 3 and -3, 5 and -5, and so forth. So if we have the odd integers and we add them, that's the first operation we'll look at. What's going to happen? Well, if you add any number and its opposite, 1 plus -1, you get 0, and 0 is even. So right away, we can see it's not closed under addition, since the addition operation creates an even number, which is not in the set we're given. So it's not closed for addition. Also, for the same reason, excuse me, is not closed for subtraction. If I would just reverse this, -1 minus 1, here I get -2. Or I could have done, of course, 1 minus -1 and get +2. In both cases, these are even numbers, right, which are not in the original set we started with. So it's not closed for subtraction as well. I'll jump to division. It's not closed for division because, well, it's pretty similar to before here. If I take 1 and I divide it by 3, I get 0.3 repeating, right? I create this decimal or rational number, but it's not in the element of odd integers. So it's not closed for this operation as well. Multiplication, though, it is closed for. If you take any odd number, multiply it by another odd number, you get an odd result. Essentially, you might think, oh, it's an odd amount of odd groups, right? And that is an odd value. Also, these numbers here will never become even because you're never giving it, right? They'll never have 2 as a factor. You need to have a factor of 2 to have an even number. But since none of the numbers you start with ever have a factor of 2, you can't create an even value. So it is closed for multiplication. This set right here, we want to see when is this one closed. Well, it's not closed for addition, because if I take any element, like 1, and add it to itself, well, not any element, excuse me, but if I take 1 and add it to itself, I get 2. And that's not in the original set. If I take -1 and add to -1, I get -2, which is also not in the original set. So it's not closed for addition. Subtraction is also not closed for. 1 minus negative 1 is positive 2, which is not in the set as well. So it's not closed for that. Division, we have, let's see, we have 1 divided by negative 1, which is negative 1. We have 0 divided by 1, which is 0. And we have 0 divided by negative 1, which is 0. And we have negative 1 divided by 1, which is negative 1. So far this seems closed. I'm not using division by 0 yet. I think, right, because, well, positive or negative 1 or 0 over 0 is undefined. So we'll come back to what that means in a moment. Let's look at multiplication. So here, what happens if we multiply? Well, 1 times negative 1 is negative 1, so that's okay. And 0 times anything, 0 times a, we'll say, is still 0, so it doesn't matter which combination we look at there. And negative 1 times itself, right, negative 1 squared is positive 1. And 1 times itself is also positive 1. So multiplication seems great as well. So which of these two would you pick, right? They seem to both work. Well, I'm going to pick multiplication, right? Because division has this scenario right here, the undefined scenario. So we don't know what type of element this creates, the undefined scenario. However, it does create a new type of value which is not in the given set. So it's not closed for division. So here I would choose multiplication. So again, when you test for closure, you really have to think about what operations you're looking at, because each operation might be different within any given set. But what you do is you look at the operation, you combine all the elements in any way you can, and try to look for a way to create an element that was not there before. And if you can, it's not closed. If you can't, it is closed for that operation. Alright, hope this helped.